a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. This lesson is often a frustrating one for not only the student but the instructor, because a student frequently wants cut and dried methods for solving all problems of a business nature, and it doesn't exist. One must learn a great, huge pot of techniques for many, many problems. So all that we can hope to do in this tape is to give you an indication of a strategy for approaching such problems. First, we're beginning to realize that percent is used constantly in business. Let's look at just a few of the business concepts which use percent. Markup, discount, profit, interest rate, taxes, salary increases, commissions, and the list goes on and on. Of course, this is the purpose of accounting, bookkeeping, and business courses. The point we're making is you not only must know mathematics and various techniques with the calculators and percents, but you in fact must know each of these if you wish to work a problem involving them. So in this lesson, we will simply look at fewer of the simpler ones and leave the more complicated ones to their appropriate business course. A great number of those problems can be restated as either simple percent problems, proportions, or simple algebraic statements like those taught so far in this course. We'll give but a small sample of them here. Other examples will constantly be encountered through your own experience and other courses. To solve such problems, first be sure that the terminology is well defined and understood. If you don't know it, stop, look it up, or ask. Be able to state how the different terms are related to each other, preferably by a mathematical relationship. Again, if you don't know, stop, look it up, or ask. And finally, state your problem as simply as possible using all pertinent information. And at this point is where mathematics usually begins. Let's start with a simple type. The cost of a jacket is $24.30. The markup is 40% of the cost. What is the selling price? Now it's important to realize here you're looking at this from the point of the merchant, not the buyer. So let's look at how we can dissect this problem. Let's look at the words we're using. And of course we know that business courses will be much more precise about these than we will, and they must be. Okay, first, cost. That's what the merchant pays for the item. We'll use the letter C to stand for that in our future statements. Markup. That's the amount which is added to the cost in order to get the selling price, which is what you and I would pay for it. So for markup, let's us use the letter M, and for selling price, let's use the letter S. Remember at the beginning of this course, we said that the letters simply stand for some number, and the reason we have different letters is to help us to remember what it's standing for. Now, how are these three things related? Cost, markup, and selling price. I think you know that already, but if we didn't, we would ask the business instructor, and he would tell us that selling price is simply the cost plus markup. That's a simple enough statement, but notice how we're using those math symbols to say it, and that's going to be part of our clue. Now let's begin to get statements about our problem. Let's go back and get some information out of it. First, they wish to know the selling price. So at least we've identified what we don't know, the selling price. Now let's see what else the problem is telling us. Okay, the cost of the jacket, $24.30. Then let's state that mathematically. There, the cost. And of course that's what the merchant paid for it from the wholesaler or whoever he buys it from. Okay, now do they tell us anything about the markup? Now notice here, the markup is 40%, 0.40, of the cost, which they told me was $24.30. So although they didn't tell me what the markup was, they very definitely told me how to figure it out. So let's do that in case we can use it. And we have a markup of $9.72. So let's take that information back to our statement of the problem. Now, notice that the mathematical statement of the problem, once we fill in what we don't know and what we do know, is now instructing us exactly what is to be done. The selling price is the sum of those two numbers. So performing that addition, we get, so the selling price would be $34.02 if it were to meet all of our conditions. Now naturally at this point the merchant would probably change this to 34 or 34.50 to get a more attractive number, more even number, rather than down to the pennies. Now naturally after you work many problems like this, you won't go through such a tortured movement as we did. You'll simply solve it. So the strategy we're giving you is what you do if you approach a problem that's relatively new to you. Notice how the use of algebraic variables helped to get away from the confusion of words, and an algebraic sentence can be solved, whereas a verbal sentence cannot, at least not so easily. Let's try another one. The regular price on a stereo unit is $3.40. During a sale, it is to be discounted 20%. What will be its sale price? Okay, now you probably have done these in other classes and it's automatic to you. But let's use this simple problem to sort of tie into our strategy a bit more firmly. First, can you identify the technical words we should be able to define before we start? There's the regular price, there's a discount, and there's a sale price. So our first point is to identify these, then ask what are they and how are they related. That's not a math question. That or those are business questions. Now in this easy problem, we'll presume you know what those are already. But for the regular price, let's use the letter R. The discount rate, let's use small r. The discount itself, let's use D. And the sale price, let's use S. What letter you use is really up to you or your employer or your teacher. But now what do we know about these? Well, we know the regular price is the discount plus the sale price. Or the sale price is a regular price minus the discount. Whichever way you say it, you're saying the same thing. But we also know that the discount is so much percent of the regular price. Okay, now let's fill in these relationships as best we can from our words. So back to our problem, and we bring to it our two formulas of the now known relationships. So let's see what we can fill in from these. The regular price, okay, here's regular price, and they told me that's $340. But also, I might need it over here, so $340. Now, what else do they tell us? During the sale, it is discounted at 20%. So they're telling me the discount rate is 20%. What else do we know? What will be the sale price? So they're telling us it's a sale price we want to know. Okay, let's stop and just look at this. Once we have gone from the words to the mathematical statement, if we've done a good job, we won't have to go back to that. So let's see if we can just stay here and find that sale price. Notice over here it says the sale price, which is what I want, is $340 minus the discount, but I don't know that. But over here it says the discount is 20% of this. But this is not quite fully mathematics. 20% mathematically is 2/10. Of is times, 340 is mathematics, and this says discount is simply that times that, which is $68. But now that I know the discount, I can put it up here, and now it's clearly telling me that selling price is the difference of these two, which is $272. Now, if you understood these things and if you have worked problems like this before, you probably wouldn't do it this way. We're trying to use this as a vehicle to find out how we can attack problems we don't know by going through, first to be safe, problems we might know. So the general strategy, once again, was this. Identify in the statement of your problem the technical things being dealt with. If necessary, define the terminology. Get some letters to stand for those things. Then state the relationships between them. And these relationships are relationships you must already know, you must read, or you must ask somebody. Then finally take those statements, those relationships, back to the problem, fill in what you do know, and usually at that point the mathematics will direct you to its solution. Now, as you can see, we haven't even started to scratch the possibilities. But perhaps these few problems will give you an indication about how you can better organize your approach to such problems. Please know that being good at verbal or application problems is simply a matter of experience. And experience means reading worked examples from the textbook possibly, watching somebody work examples, and in this case it's going to be me, and above all else, a willingness to stumble and experience frustrations. So for the remainder of this lesson, I won't teach. I won't show you how to do things because, in fact, that's not possible. Every problem is different. I'll simply let you experience watching me work some examples. And try to store up those examples either in memory or in your notes so that you can use them to interpret other problems which might be the same or similar to the ones that we're going to work right now. So here we go. Have your problem in front of you and have scratch paper so that you can make notes as you read. Because remember, our first task is to ask the question, what are they saying? Okay, so we have a new car that depreciates 15% during the first year. Its original cost was $12,500. What is the value at the end of the first year? Now let's begin to talk to yourself, and you'll find this is really a very simple problem. We're going to depreciate 15% of what? Well, of its value, and that's right here. So we're going to take 15% of this, and that's the amount of depreciation. That's fairly obvious in this case, isn't it? It's a good simple problem. So we want 15% of means times $12,500. So now this is simply telling me to multiply. 15% tells me what by. It's the of that tells me I'm going to multiply. So I do this either by hand or by calculator, and I get $1,875. Now be careful not to quit at this point because this is only the depreciation of that first year. And they want to know its value at the end of the first year. And of course the value is what you get after you have depreciated or taken this off of the value. So common sense now says I'll take its current value, the first year value, subtract the depreciation, and what is left is its new value at the end of that year. So at the end of the first year, by depreciation alone, the car's value will be $10,625. So see, as I talked to you, as you work problems, you will talk to yourself. And you're always asking not how do I do it, but what are they saying and what do they want? and that should tell you what to do. So be very, very free about talking to yourself over and over and over until the problem becomes crystal clear. Let's do another one. Your labor union negotiated a new contract which would increase salary by 5.25%. What would be your new salary if you were earning $9.32? Now, is this as easy as the last one? You're going to increase this by 5.25%. So that means the increase is this times this. But I don't want the increase, I want to know what my new salary is. Well, if we know the increase, we can just add it back on. Or you could think this way. I'm going to increase this, and of course this is always 100% of itself, by another 5.25%. So what we have here is that the new salary, and let's call that N, is 105.25% of the old salary. Now, if you see this, this will save you a little bit of work. Because if we did it the first way, where we take 5.25% times this, then we have to turn around and add it back on. But here, we'll just have one problem, and when we're done, we will have the answer in one move. So this has a new salary and an old salary, but the old salary I know. It's the 932. So what do we have? We have a simple sentence, is of and percent, and the only unknown is the one I want. So this says the new salary is, and if we don't like that 1/4 as a fraction, we can change it to its decimal equivalent, but the percent is still there. So now we can get away from percent by moving it 2 places away. Of means times 9.32, and since this is money, we would know to round to the nearest penny, and we simply do the indicated arithmetic. This times this, and we're done. And doing that either by hand or by calculator, we get $9.81 per hour. This was fairly simple, as was the last one, and that's the way most textbooks operate. They'll take some fairly simple problems where it's pretty obvious what you're going to do just by a simple reading, and a clear understanding what they're saying. Then very slowly they begin to get more and more involved, more words usually, or else they begin to give you more and more pieces that have to be put together. Consider this next problem. A stereo set is advertised to sell for $110. Markup must be at least 33.33% of the cost. What is the most the store can afford to pay for the stereo set? Now first let's begin to write down what they're telling me in simpler mathematical expressions. Okay, so we want the selling price to be $110. Okay, let's make a note. The selling price we'll call S temporarily, and they're telling me that S is $110. They say markup must be 33.33% of the cost. Okay, so they're saying markup is 33.33% of cost, or the wholesale if you would. Okay, so we have just restated this in mathematics. Now what else? What is the most the store can afford to pay for the stereo set? So cost is what the store pays, so it's the cost that they want. Now if you see what to do, then do it. If not, then you begin to ask yourself, what do I know about these kinds of things? Well, let's see. We know that selling price is cost plus markup. Okay, in this particular case, we know the selling price from up here, so that will give me 110 is equal to cost plus markup. But this says markup is to be 33 1/3%. So let me try something here that's a little bit different from, and see if you can compare this with something we've done a moment ago. I left that alone. And markup, I'm going to replace by what this is saying it is 33 1/3% of cost. And I'll replace the of by times. Now, perhaps by writing it this way, you can see more easily that anything is 100% of itself. So can you see that I have 100% of cost plus 33 1/3% of cost, or if you would, 133 1/3% of cost. Now, if you see this, we're just about done. So let's follow this through, hoping that you did see it. Now, if you wish, we can get rid of the percent by moving a decimal point 2 places away. So we have 1.33 1/3 times the C. And the question is, what do we do about this 1/3? Well, we could get rid of it by making it exact, or we might recall that 1/3 is 3, 3, 3 forever. So we can add enough decimal points to give me the accuracy I know I want. Now we have something times the variable equal to something. So we undo multiplying by dividing both sides by the same quantity. And this is cost is 110 divided by this. And since we have a lot of decimal points there, it probably would be better to do this division by calculator. And rounding off to the nearest penny, we can see that that's $82.50 is the cost. Now, it was this sentence and this fact up here that told me the selling price is going to be the original cost, which is 100% of itself, of course, increased by another 33 1/3%, which tell me if I increase 100% by 33 1/3%, I get 133 1/3%, but percent of the cost. Now, if you see this will help you quite a bit in future problems, which will be very similar to this. In fact, let's look at that problem once again, because the purpose of working these problems is not to just get an answer, is to build a model for future problems similar to this. So in solving this, we went through a lot of contortions trying to find out just what are they doing. So when you're done, back off and see if you can see the whole thing in a smooth train of thought that you can transfer to another problem. So in looking at this, you might be able to conclude this. In all cases, selling price will be equal to cost plus markup. This is always the case. And it is indeed always the case that anything is 100% of itself. So this is just another way of saying cost. And if it occurred that the markup was 33 1/3% of the cost, then we have 100% of cost plus another 33 1/3% of cost, which now becomes 133 1/3% of cost. This step through a few more problems, will be eliminated, as would this, and you'll simply think that, gee whiz, if I have 100% of cost and increase it by 33 1/3%, then it's obviously 133 1/3% of cost, and that is the selling price. And perhaps you might recall that 133 1/3% is 1, and 33 1/3% is 1/3 of cost. And you might also recall that this is 4/3 times cost. And in this case, we don't have that long decimal, do we? But the selling price, we knew we wanted to be $110. And we can solve this simple equation several ways. One is to multiply this side by the reciprocal, because any fraction times its reciprocal is 1 times the cost. But then I have to multiply the other side of the equation by the same amount. And this is easier arithmetic than we had with the decimals. You see that? But always remember that anything is the same thing as 100% of itself. And sometimes you need to think in terms of percents first, particularly when you're increasing or decreasing something from what it originally was. So if you can begin to think this way, then you are beginning to think mathematically. Can you apply that directly to this? A discount house advertised that they plan to sell all appliances at cost plus 10%. Now right here you want to say that my selling price is going to be the cost, which is 100% of itself, plus another 10% of it. So in fact the selling price is 110% of cost. Do you see that? With practice you'll go from here directly to here without all those many steps we had in the previous problem. But in this case, Sue bought the set for $740, which is the selling price, and we can find the cost. So this is 740 is 1.1 of cost. Divide both sides by the multiplier, the unknown. Do the arithmetic. And we get the cost, but that's not what they wanted. They wanted the profit. Well, the profit, of course, is the difference between the selling price and the cost. So we follow through on that statement. And we're done. And of course, you need to see many problems. The 3 or 4 that we've done here just barely enough to point your head and mind in the direction we want to go. But you need 10 times as many to become fairly comfortable. This is your host, Bob Fennell. We'll see you at the next lesson and the next chapter.